In this video, I'm going to derive for you the law of cosines. The law of cosines is a formula that allows us to solve any triangle's sides and angles. The formula is a squared equals b squared plus c squared minus 2bc cosine a. In terms of labeling the triangle, I'm going to use the same scheme that I did with the law of sines. In the lower left, we have capital A for the angle. The side opposite it is going to be lowercase a. On the lower right, we've got capital B, and the side opposite it will be lowercase b. Across from capital C will be lowercase c. To start the proof, I'm going to drop an altitude from C. This gives us right angles, which I'll mark accordingly. In dropping the altitude, we divide the big triangle into two smaller triangles. I'm going to call them Roman numeral 1 and Roman numeral 2. Now, this is a little bit more complicated than the derivation for the law of sines. The entire length of the base, AB, we're going to call C. But I'm going to split that into two little pieces. I'm going to call this piece over here x. And if the whole base is c and a portion of it is x, then the other portion is c minus x. And again, this altitude I'm not going to call a for altitude because we already have an a over here, but I'm going to use h for height. Okay, starting with triangle 1. I'm going to use the Pythagorean theorem, and I'm going to say x squared plus h squared is equal to b squared. Easy enough, right? Now I'm going to move to triangle 2. This is going to get a little more complicated. Now one of my legs is c minus x. So it's going to be c minus x squared plus h squared is equal to a squared. I'm going to work with this, and I'm going to expand left-hand side by foiling this out. So I end up getting c squared minus 2cx plus x squared plus h squared equals a squared. Now, there's an observation to make, and that is, in this portion of our answer, we've got x squared plus h squared, which is exactly what I have over here. So I can substitute b squared in place of x squared plus h squared. In doing that, I get c squared minus 2cx plus b squared is equal to a squared. Now I'm going to move this b squared. I'm just going to move it in front. So I'm going to say b squared plus c squared minus 2cx is equal to a squared. Now if you look at what we have written down and what we're going for, which is up here in blue, we're starting to really get a similar situation. We do have to do a little bit more work, so I'm going to come up here. The next thing that I'm going to do is I'm just going to flip-flop the left and the right-hand side. So I'm going to move the a squared over here, and I'm just going to write it like this. A squared equals, and then the other side said b squared plus c squared minus 2cx. So it's really looking like what we wanted to get to, except there's no x in this equation, and we've got to get rid of this x here. The way we're going to do that is by using this triangle over here, Roman numeral 1, and the cosine ratio. If I pick A as my reference angle, I can say that the cosine of A has the ratio adjacent to hypotenuse. Well, now the adjacent is x, and the hypotenuse is b. So cosine of A, which is adjacent over hypotenuse, is x over b. If I cross multiply and solve for x, I get x equals little b cosine A. And now what I can do is I can plug that in to this over here. So we're going to do one more rewrite, maybe even two more rewrites. Let's see how this goes. A squared equals b squared plus c squared minus 2c. Now instead of x, I'm going to write b cosine A. Now it's looking so close to this, except these guys are reversed. Well, the deal is these two are being multiplied together. So it's negative 2 times c times b, or negative 2 times b times c, however you're looking at it. Multiplication is commutative, so the order doesn't matter. As an example, we could say 4 times 5 is the same as 5 times 4. It just doesn't matter. So I'm going to switch this around, and instead of saying CB, I'm going to say BC. And if we do that, we get exactly what we started with. So here's the derivation for the law of cosines.